So let me put this way. I asked second period today, hey, you guys have heard of this before, transformations? Yeah, we did it in middle school. And then we did the notes, and it was like I was teaching a new language. So I don't know how well it was taught in the middle school or how well we picked it up, but I'm going to go a lot slower than I did second period. And it also didn't help either that one student told me that she had her sister take her transformations test last year. So that might have been a problem too, why maybe we didn't pick up some of the concepts, but just saying. All right. Was this last year you guys did this? Reflections, rotations, translations. Okay, some people are shaking their head yes, so I assume all of you went through it. All right, so here's basically in a nutshell what we're doing here, guys. I'm going to take a figure. All right, I'm going to take a figure. Let me copy this. All right, oops, one last. And I'm going to do something with it. Move it around. Maybe I'll rotate it. Maybe I'll flip it. Maybe I'll make it bigger. That's a transformation. Here's my original figure. I'm going to do something with it. Here's my ending figure. Whatever I did is called a transformation. Now, sometimes when I do a transformation, the original and the end one are the same size and shape. Anybody got a vocab word? They are what to each other?
Oh.
This word is like at least top 3 of the year. That congruent. They're congruent. They don't change size or shape. Right? Congruent.
Oh boy.
All right. So sometimes when I do a transformation, the two end up being congruent to each other. They don't change the size or the shape. Anybody know what the transformation's called when they actually are not congruent? One's bigger than the other or smaller than the other. Anybody remember that transformation? When I make a figure bigger or smaller? Hi, Tammy.
I think it's a dilation.
A dilation, yes. Remember that one? We'll talk about that at the end of the unit. Here's where I want to stick to, though. If I do a transformation, the lengths of the segments stay the same and the angles stay the same. So they're congruent to each other. We're going to refer to that transformation as a rigid motion. What's one thing I could do to this triangle and it would still be congruent to the original one? What's one thing I could do to this right now? Sure.
Rotate it.
Okay, everyone agree if I rotate it, is it still the same size and shape? So a rotation is a type of rigid motion. Anybody else? What else could I do to it other than just turn it? Jonah?
You like slide it.
I could translate it, slide it. All right, so a translation is a type of rigid motion. Okay, there's one that's not. What did we just talk about? What changes the size? A dilation. So a dilation would not be a type of rigid motion. Rigid motion means the original and the ending are the same. So let's talk about a dilation real quick. It changes side length, but does not change the angle measures. Okay? And I don't want to talk much about dilation at all because it's a big topic, 2-day topic at the end. All right, I've been talking about the figure we start with and the figure we end with. I want to put a vocabulary term to each now. The figure we start with. The figure you start with is called the pre-image. That's the figure we start with. We do something to it. We slide it. We rotate it. We dilate it. The last figure we end up with is called the image. Okay, that's called the image. So I want to start using that vocabulary with you. What we start with is the pre-image. What we end with is the image. And in between, we got a transformation going on. Maybe it's a rigid motion, maybe it's not. All right, so number 1 here. Everyone see my pre-image on the left, my image on the right. I did some type of transformation. Would you classify that transformation as a rigid motion here? Did a rigid motion? I don't want to know what I did. Don't give me dilation, rotation. I just want to know, does this look like a rigid motion happen? Does this look like a rigid motion happen from my pre-image to my image up here? A lot of you guys are saying no. Why not? Are these congruent? No. So this is not a rigid motion. I'm going to say no because side length is different. Side length is different. And what do you look at number 2 now? Pre-image on the left, image on the right. Does it look like I performed a rigid motion there? Yes, no, maybe? What do we think? Rigid motion? I don't know what I did, but at least, yeah, it's a rigid motion. Because side length and, that's not good enough if side length and angle measure look the same. So rigid motion, the original pre-image and image are congruent. We're going to talk about one type today. One type today and tomorrow, actually, called a reflection. 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 Everything in this unit has a symbol because I don't want to have to write out the word reflection every time. The symbol for reflection, a lowercase r. Lowercase r. Well, why is it an uppercase, Mr. Carleon? Because that's for another one we're going to talk about after break. Lowercase r. Have you guys heard of the term subscript? When you're writing letters, a subscript? All right. Subscript is something that's written kind of below it. All right. You will always see the lowercase r, which means reflection, and then something will always be written below it. And that something is the line you reflect over. So line of reflection will be put here. Whatever line you want me to reflect over will be put in the subscript. The subscript. All right, here's where I got to slow it down because I lost a lot of people second period. Let's first reflect a point. All right, before we get to reflect a shape, let's reflect a point and see how that works. So the point I'm going to reflect first is 2, -1. So can you all go to your graph right now I provided and graph 2, -1. And we're going to call that point A. And I'm just going to blow it up because it's a little small on mine. Here's the first thing I want you to do. Take 2, -1. Ready? Slow it down for everyone. What's that the symbol for? Reflection. Over what line? What's in the subscript here? So I want to take point A where it is right now and flip it. Reflect it through the x-axis. Okay, how's that get done? Some of you guys may know from middle school days, but I'm going to assume nobody knows anything here, so I'm going to slow it down. I need to take point A and flip it over my x-axis. First thing, how many units away is A from your x-axis? 1 unit away. When you do a reflection, the distance needs to stay the same from the line you're reflecting over. So if I'm going 1 unit to get to the x-axis, I need to match that and go 1 unit in the other direction. Distance has to stay the same. Distance stays the same between your line of reflection. Next, I don't want to call this point A because point A is 2, -1. This is a totally different point. And no, I'm not calling it B or C or whatever favorite letter is. Anybody know how I represent it after it gets transformed somehow? Hi, Lauren.
Hi. A prime.
Yes, we do a prime symbol on top. So A This is called prime, A prime. That tells you something's been transformed. And now you can tell me what's my new point. What is my new point now? A prime? Just name it. What are the coordinates, I should say? What are the coordinates? I should be doing this. I'm sorry. I know you guys don't like it when I just ask for just a yell out answer. What's that new point now? Whoa! 5, 2, 1. You're like on high alert since that fiasco we had a couple weeks ago, Greg, right? 2, 1. Is everyone all right? Now, let me go down now. Point A, still 2, -1, but now what do I want to do, everyone? Reflect it over the y-axis now, yeah. So now do the same thing. Distance stays the same. Y-axis, how far is A away from your y-axis? 1? Meg, how far is A away from the y-axis? 2 units. So I need to make sure distance stays the same, and I go another 2 units to the other side. 1, 2, 1, 2. And you could still refer to this as A prime because I'm going back to the original. So what are the coordinates of my new point now? 15?
-2, -1.
-2, -1. Are you guys all right? I know, I get it. Some of you in here are like, this is so basic. This is no problem. But I'm just going, assuming we're all starting from scratch. Because this is basic. I'm about to get on to the honors level here in a second. All good? Next one now. Go to the top right. Now take A. Ooh, how about this one, huh? Reflect it over what? Y. I'm going to do the bottom right one. Y equals 2? I want you to reflect over that line. All right, let's go back. You just need a refresh here now. Y equals 2. What does that line look like? I know it's straight. All lines are straight. Thank you. Y equals 2. Anybody remember what that looks like here? Just Y equals 2. Take a guess. Jonah?
Would it just be a horizontal line that goes through 2?
It's anytime Y is all by itself with a number, it's horizontal. X by itself with a number would be vertical. Okay, so that's something we got to keep in mind this unit. Y by itself is just a horizontal line. So don't feel like you need to graph it on yours. I just want to show you on mine. That's Y equals 2. Horizontal line going through 2. My rules don't change though. Count. How far away is point A from that line? Count. So I can match the distance. How far away is A from that line? 9. How many units away is it? 3. 1, 2, 3. So guess what? I'm going to go 1, 2, 3 in the other direction. Name A prime now. 3. Eva, what's A prime now? 2, 5. Y in a number, horizontal. X in a number, vertical. Vertical. Any issues before I get to this last big one here? Whoa, boy, look at that last one. You guys all good? Okay, I want to take out this horizontal line here so that it doesn't get real confusing. Just give me a quick second here. Oh, here it goes. Yep, there it goes. I knew it as soon as I touched the mouse. Oh. Can we get it back? Can we get it back? Can we get it back? Yes, we can. All right, let's do what I wanted to do. Okay, good. All right, now. Eva, what was that point again?
5.
Thank you. Okay, last one. How about this line? Do a reflection over the line y equals x. Oh, kidding me? Anybody know what that line looks like, first of all? I'll give you guys credit here. What's this line look like? Hi, Jonah.
Isn't it just like a diagonal line
Just anywhere I can put a diagonal line?
that goes to the origin?
Okay, here you go. Ready? I want you to take a 2, -1 and flip it over that line. Oh, we got a problem. You're not counting here. You can count for a horizontal or a vertical line how far away the point is, but you can't do this for a diagonal line. So here's what I'm going to do in that case. I'm going to give you a rule to follow. Anytime we reflect over the line y equals x, where does the point go? Because you can't, everyone agree, everyone see what I mean when you can't count? I can't count how far A is from the line. I'm not going to, oh, this is like 2.5 boxes. No, cut it. That's garbage. All right, you're going to think I'm nuts, but here we go. Y equals, this is like a classroom sing-along here. Y equals,
X.
Y equals,
X.
your Y equals,
X.
and then let's read it backwards now. Your X equals,
Y.
your X equals,
Y.
anybody know what I want you to do with the coordinates? Your Y is equal to your X is equal to your Y. Anybody know what the rule is going to be? What should I be doing with the coordinates? Flip them. Your Y is now your X is now your Y. So 2, -1 would go where? 2, -1, 2. And take a look just on mine, because I can clean mine up and you guys can't. Here's 2, -1. Maybe. And here's -1, 2. See how it's been flipped over that line now? All right, makes sense. All right, just by the looks of the graph, I flipped it over. Questions? So whenever I come upon y equals x, no counting, I just remember the rule, I got to flip the coordinates. Flip the coordinates. Questions? I'm sorry that was super slow, but I want to make sure we're solid. Now you get to show me your expertise on the next one. Take triangle ABC for me. Reflect it in the y-axis. Reflect triangle ABC. So graph it first. Go ahead and graph triangle ABC. Graph it through the y-axis. And then, yes, at the end, tell me what your new coordinates are, please. Graph and state your new coordinates. Whew. All good? Lovely. In the Y, not the X, in the Y, everyone, in the Y. Count distance doesn't change. In the Y, know your axes. Know your axes. All good? Okay, how about your coordinates for me? Coordinates, A prime, B prime, C prime. Lay them out there for me, kids. Lay them out there for me. Oh! 17?
A prime equals -1.
Darn right it does. Keep rolling.
Oh, -4, 3. And, -2.
Yes. Any issues? Going? All right, let's keep grinding. 0, 5. 0, 5 is point X. Oh boy, do we know where that point is? On the graph, 0, 5. First thing, take it, reflect it through the line X equals 2. We just talked about Y equals. What's X equals again? What type of line? Don't say straight. X equals 2. What type of line? 10?
Vertical.
Vertical, going through 2, everybody. So 1, 2, I got this vertical line right here. Please reflect X through that vertical line. And let me know what the coordinates are for X prime. Yeah, dig deep, dig deep. Oh, 23? 4, 4, 5. Good catch. X prime is 4, 5. All good. Okay, in all seriousness, now you got to start reading a little bit more carefully. Reflect X prime. So here, unlike the first batch of problems we did, I'm not going to go back to the original coordinate. Now I'm going to stay at 4, 5, X prime, and reflect it through Y equals -3. What type of line? -3. Y equals -3. What type of line am I looking at? 11?
Straight through horizontal.
Thank you for saying horizontal, because I was about to grill you if you kept saying straight line. There it is right there. X prime, remember, X prime. And I did this on purpose. I want to see how many of you are going to panic. X prime through that line. How many of you are just going to, I ran out of graph. I ran out of graph. You expected me to do this. Where's my graph? Please don't do this either. Oh, this is so. I ran out of graphs, so I'm going to make more. You don't need to. Oh, God. Oh, that makes me cringe. Use some simple algebra. Before I ask somebody, what do I call this point now? Because I'm changing the X prime coordinate. So I can't call it X prime again. X. You'll be right. Serena? Darn right it is. Double, meaning I transformed the original twice. And where do you end up after you reflect through that line? Come on now. Make us all proud. 20?
4, -11.
There you go, Jonathan. Good. Did you draw in those extra lines too, I bet? No? All right. Questions, comments? Is this that bad? No? Or was just second period being dramatic? Probably that. And then, yes, if anybody's watching this from second period, you heard me. I'm laying it down on you. I heard you made fun of us on the video. I wasn't making fun. I was making the truth. Making truths. Okay, now I got a segment, so connect those darn things. Connect F and G. Boom. Because we can reflect points, we can reflect shapes, and hey, yeah, why not? We can reflect segments. First thing I want you to do, lowercase r, reflect it through y equals x. Remember, that's my diagonal line going through the origin. I don't count. I remember the rule. I remember the rule. If you need to refresh, look back when we did it, because I'm going to ask somebody for F prime and G prime. Six, when you're ready. F prime. Well, first of all, let me ask you about the rule. What do I need to do to my coordinates?
You have to swap them.
Swap? I like that word. Nice. That's a word I don't hear too often. Anybody swap? You don't hear that one too often, huh?
I don't know.
I like it. Good job. I liked it. Good. You're right. 3-0 becomes what?
0-3.
0-3. I may steal it. 4-3.
3-4.
3-4. And just take credit for it. So. All right, now we got a new line. Okay, y equals x. We're good. We swapped them. All right, we swapped them. We're good. Now, take FG, the original. I should probably graph. Sorry. 0-3. And 3-4. And by the way, let me just, hey, does it look like we reflected over that line? Yeah, it does. Looks pretty good. Now what I want you to do is, let's go back to FG, the original. And now I want you to graph over this line, y equals negative x, which looks like that. Can we count? No, this is not horizontal or vertical. So yes, this is the second and last time I'm going to have to remember a rule. Y equals x, I flipped it. Y equals negative x. Well, it is a version of y equals x, so I do still want to flip it, but I got to do a little something extra now. I do still want to flip it. And anybody think you know what you're going to do after you flip or swap them? Excuse me, swap them. After that, what are we going to do? What do you think? Change the signs. Yep, change the signs. So when I reflect through the line y equals negative x, I'll swap them and change the sign. So 3-0 would become what? Swap them, change the sign. 3-0 will become 20. Yep. And G will become 2. -3, -4. And I promise you, those are the only two rules I'm going to have you remember. Y equals x and y equals negative x. Those are the only two rules I'll have you remember. And then take a look real quick. Let me graph it on mine. 0, -3. And -3, -4. There you go. Looks like we flipped it over that, the original over that line. Looks pretty good. You guys all right? Questions? Because I'm going to have you do this last one on your own. Every question I've asked you guys today, I've told you what line to reflect over. Now you tell me what line to reflect over. I'll give you both the pre-image. Take a look. I'll give you both the pre-image and the image. What line did I reflect over? All right. So now we're going in reverse now. So go ahead, take your time, graph triangle ABC for me. Graph A prime, B prime, C prime for me. And then see if you can give back what line we reflected over. It's easy to see on your graph, isn't it? That line. That's the line I'm going to reflect over, but I need a name for it, though. I need an equation for it. All right, I do need an equation for that. Name that line. What's the equation of that line? We can draw in easily, but how do I name it? 6.
X equals 3.
X equals 3. It's vertical. We talked today. Any vertical line will be x equals a number, and it goes through 3. Perfect. X equals 3. Questions? Anything? What's up, Griff? Go ahead. Yeah.
Is it okay to say R subscript X?
Yeah, that's fine too. Yep, absolutely. Perfect. Good. Yep. All right. If you need graph paper for tonight, why don't you get going? We still have 10 minutes, so let's not waste it, right? If you need graph paper, come on up. If you need a couple slices.